throwing one die, I am asking you, of course, what is the probability? Probability is favorable. I would like to write it any number of times because this is the only formula we are using all the time, right? Favorable by total. Yes, in this case, you tell me only one die, single die I have rolled. What are all possible outcomes? 1, 2, 3, 4, 5, 6, right? Total possible, all possible outcomes. All possible. You tell me what is the probability of getting an even number? That is my question. You tell me. You have rolled or you have thrown a die. You have got 2. Of course, you may get 3, you may get 4, 5 or 6. All possible outcomes are 6. Now my question is, what is the probability for getting an even number when I throw this dice? This die, you tell me. What is the denominator? Total. If you have thrown one die, what is the total number of outcomes? 6. Now coming to numerator. What is the event? Even number. See, how many even numbers are there of this 6? You tell me. Is it even? No, this is an odd number. This one even. This one even. This one even. So 3 even numbers are there. So 3 are favorable to your event. So numerator is 3. So probability is 1 by 2. You tell me what is the probability in the same way. What is the probability for getting an odd number when I roll or when I have thrown a die, single die? You tell me what denominator is total 6. Coming to numerator, odd number. The event is odd number here. You tell me how many of these 6 are favorable to this event? Yes, how many are odd numbers? Yes, odd number. 3 odd numbers are there. So 3 are favorable. So your numerator will be 3. So probability is 1 by 2. Right? You observe one more thing here. See, 1, 3, 5 are odd numbers. 2, 4 or 6 are odd numbers. Of course, these two, of course, they are not complementary events, but they are events. This event and this event, see, outcomes of these two events together are forming this complete all possible outcomes of the experiment, is it not? In this case, what we have discussed earlier, thus that type of events are called complementary events of each other. So getting even number and getting odd number are complementary events, is it not? Complementary events. So what we have observed, the sum of these probabilities is 1. I can write probability for even number plus probability for not an even number. Both are same. That is nothing but odd number. Yes, 1 by 2 plus 1 by 2 is 1. In the same way, I can write probability of an odd number plus probability of not an odd number. Not odd. Not odd means even, of course. These two probabilities are, of course, if you add them, 1. So this is some examples for using the formula P of E plus P of E plus P of E bar is equal to 1. So this is about complementary events, right? See, next point is this. You have rolled one die. Yes. You tell me what is the probability for getting phase 10? Tell me. You have thrown a die. What are possible outcomes? 6. These 6 are possible. My question is, what is the probability of getting phase 10? Tell me, if you throw this die, can you get 10 on this phase? No, it's not possible, impossible, because there is no 10 here, only 6 is possible maximum, right? 10, where do you get 10 from? Nothing, nowhere. So, favorable or 0, total is of course 6. So, probability is 0 by 6. Tell me, what is the probability of getting 100? When you throw this single die, is it possible to get 100 here? No, not possible. So 0 by 6, that is 0. What is the probability? Same next question. What is the probability of getting Alia? What you have done? You have thrown one die. So what maximum you can get? You may get 1, or you may get 2, you may get 3, 4 or 5 or 6, but where do you get alia from? No. So denominator is 6 total, numerator is 0, 0 favorable, nothing is, no outcome of this 6 is favorable to this event. So your numerator is 0. So probabilities, these 3 cases if you observe, probabilities are 0, right? Getting 10 on the face, getting 100 on the face, getting alia on the face, they are not possible. They are called impossible events. What are they? Impossible events. So what you have observed? Probability for getting an impossible event, or probability of an impossible event is 0. Probability of impossible event is 0. Probability of impossible event. Probability of an impossible event is 0, right? This is also a good point, right? Now coming to this, tell me what is the probability in the same example. What is the probability of getting a number which is less than 10? You tell me. Yes. What is the probability of getting a number 1 or 2 or 3 or 4 or 5 or 6? You tell me. What is the probability for getting probability of getting an even or odd number? Tell me. Yes. Now coming to this event, what is, I know all the case. We will see this formula only. What is the formula? Favorable by total. Denominator is total. Yes, you tell me. Total is 6. Now coming to numerator, less than 10. How many of these 6 are favorable to this event? You tell me, is it satisfying this condition or not? Less than 10. Is 1 less than 10? Yes. So this is favorable. See this one is 2 less than 10. Yes, we know 2 is also less than 10. So this is also favorable. 3. Yes, less than 10, satisfying. So this is also favorable. This one, yes, less than 10. Yes, that is also less than 10. So satisfying. So this is also favorable in the same way. This is favorable. This is favorable. So all 6 are favorable. So favorable cases are 6. So probability 6 by 6, that is 1. You tell me this one. Probability for getting 1 or 2 or 3 or 4 or 5 or 6. Tell me. Denominator is 6. All possible outcomes. Now coming to numerator, you see, is it satisfying this condition? 1. Is 1 satisfying this condition? 1 or 2 or 3 or 4 or 5 or 6? Yes, that is satisfying. 1 is favorable to this in the same way. 2 is favorable to this. 3 is also favorable to this. 4 is favorable to this. So how many favorable cases? 6. 6 by 6, of course, probability is 1. Now coming to this. This event is even number or odd number. When you roll a die, all possible outcomes, of course, you know, total is 6 denominator. Coming to numerator, favorable. What is the event here? What is the event here? Getting an even number and odd number. Let us see. How many of these 6 are satisfying this, right? Is 1 satisfying this condition? To satisfy this condition, it should be an even number or an odd number. You tell me 1, it's satisfying 1. Yes, the 1 is an odd number. So true, this is satisfying. Coming to this outcome, 2, is it satisfying? Yes, 2 is an even number, we know. So this is also satisfying. 3, an odd number, we know. So this is also satisfying. In the same way, all are satisfying, right? So favorable cases are 6. 6 favorable. 6 by 6 is 1. See, what you have observed here? In these 3 cases, probabilities are 1, right? 1. This type of events, that is less than 10, this one are called sure events. What are they? Sure events or certain event. Certain event. Sure event or certain event. So for sure event or certain event, what is the probability? Probability is, for sure event or certain event, probability is 1, right? For an event, probability is 1 means that event is a sure event or certain event. For an event, probability is 0 means that is an impossible event, right? For impossible event, probability is 0. For sure event or certain event, probability is 1. Can you remember? Yes, very useful point, right? Next point, see this. Next point we are going to see is this one. I am taking one more paper. See, in this case, let us take this example only. One die, you have thrown one die. Here in this case, you have seen while throwing one die, what are the probabilities you have got? 1 by 6, 1 by 6, 1 by 6, 1 by 6. In this case, 1 by 3. This is 2 by 3. Whatever may be the event, you are getting probabilities like this: 1 by 6, 1 by 3, 1, 1, 1. Here in this case, of course, 0, 0. In all the cases, you have observed that probability can be a fraction like this, numerator by denominator, right? Numerator by denominator. But denominator is, of course, in this case 6. Numerator is a number which is maximum 6, minimum 0, and any other number between 0 and 6, right? So probability will be minimum 0 or maximum 1, or any number between 0 and 1, right? 1 by 2, 1 by 2, of course 2 by something. They are all 1 by 3, 2 by 3, all between 0 and 1. So that is an important observation. So what I am here also, of course, I am writing probability formula. I like this probability. This formula I like this because this is the only formula we are using every time. Denominator is the total, numerator is favorable. That's why I like this formula. Every time I will write here while handling this topic. Probability is favorable by total. Now what we have observed, probability of an event E, any event, will always be between 0 and 1. That's what you have observed. So minimum 0. So minimum probability of any event is 0. Maximum probability is what? 1. So probability of any event cannot be greater than 1, and probability of any event cannot be less than 0. You tell me, if a statement is like this: probability of if an event A is 2.8, I have given the statement. I have said that the probability of event A is 2.8. What can you say? This is wrong. This is wrong. Why wrong? Why wrong? Probability of any event cannot be greater than 1. Probability of any event cannot be less than 0. So this is 2.8 is greater than 1. That is not possible. So this statement is wrong. Another example I am giving you. Let us consider this statement. Probability of an event is minus 1.5. That is my statement. You tell me, is it possible? This statement not possible, because probability of any event cannot be less than 0. Cannot be less than 0 means cannot be negative also. Here this is a negative number, minus 1.5. This is also not possible. This is also wrong, we can say. So this is these are the concepts of probability. See, what we have discussed so far, I have placed them, I have written them as some summary sheets, so that it will be very useful for you to refer when you start doing the exercises, or when you do revise this topic. Of course, I will provide this the last of this, the end of this video also. See this, we will see quickly. What is probability of an event E? Number of outcomes favorable to event E divided by total, the number of all possible outcomes of that experiment we have seen. At random, see, in many questions, in many occasions, while dealing with the problems of this topic probability, you will see the words. I have taken one coin or one ball at random from this. In the same way, I have I have taken one pack of cards, one card out of pack of cards randomly use, casually, all are same. At random means arbitrarily or randomly or casually or haphazardly. That is not. See this. Choosing at random means not using any particular method. There is no partiality. See, for example, here I am having four cones, right, of different colors but same size. I have put it like this. I have shuffled like this, and I am taking one without looking inside. I am taking one cone. Do I know the chance of this? No, we don't know. If they are, let us say, they are different sizes, big one, small one, let us say. If I know green and yellow are big ones and remaining two are small ones, I can simply touch them, I can feel them, and I may select a big one to get a cone of green or yellow. In that case, that is, I am following a particular method. That is, I am selecting a bigger one. That is particular method. But in all these cases, what I have dealt with so far, or we are going to deal with in coming future also, we don't follow a particular method. So that's why we call them random events. So all are of the same size. So we cannot say I am not looking inside. So I am not doing any favor to particular object or any partiality is there, right? No partiality is there. So choosing at random means not using any particular method. So all have equal chance of being chosen. Next, these words also we see: fair die, fair coin, fair die. What I have thrown is a fair die, right? Because there are 6 faces. All faces are having equal chances, right? Equal chances. 6, right? This is called a fair die. Let us say 3 faces have same face 5. Is it a fair die? No, that is not a fair die, right? Like that. Fair die, fair coin. See, let us say this coin contains both sides heads. Let us say head. How many number of times I have tossed, I will get head only. That is not a fair coin, right? But in general, we deal with only fair coins, fair dice, etc. Fair game, right? These type of words we see. In general, if nothing is mentioned, we consider the coin to be a fair coin. We will consider the die to be a fair die, and so on. See, what is this? Fair means symmetrical. Yes, this is symmetrical, same shape, all the sides, right? Unbiased. This word also we can see. Unbiased means no partiality. So no partiality. Biased means partiality is there. We have discussed. Let us say this same face 5 is there and 3 faces. Number 5 is there. Then that is a biased one. We don't use that type of things, right? Equally likely we have discussed. Equally likely means equal chances of getting. Elementary events we have seen. Elementary event means event having only one outcome. We have discussed. What is the sum of probabilities of all elementary events? That is 1. This one also, where E and E bar are complementary events. Complementary events means those 2 events together will form that complete outcomes, right? We have seen that example when throwing a die, probability of getting greater than 4, less than or equal to 4. Both are complementary events. They form complete outcomes, right? And also in another example, probability of getting odd number, even number, that also. In that case, P of E plus P of E bar is equal to 1, where E and E bar are complementary events of each other. In the same way, we have discussed this also. Sure event, certain event. Yes, what is sure event? What is that event? The chance of that event to happen is 100%. So what is the probability for sure event? 1. Probability for certain event is 1. What is impossible event? Chance of getting that event is 0%. So that type of events are called impossible event, and probability of impossible event is 0. You see this, this also we have discussed. Probability of any event lies between 0 and 1. So and maximum probability is 1, minimum probability is 0. Any probability will be between 0 and 1 only. Probability cannot be negative, probability cannot be greater than 1, right? Now one more thing, see, we are going to discuss